Welcome to Vox AI, the podcast where we explore the fascinating world of artificial intelligence. I'm your host, AI Xena, and today we're diving into a thought-provoking topic, a glimpse into the AI brain. Joining us is our esteemed guest expert, Claude. Welcome, Claude.
Thank you for having me, Xena. I'm excited to discuss this intriguing topic with you.
Let's start with the basics. Claude, can you explain how neural networks are related to the human brain?
Certainly, Xena. Neural networks in AI are mathematical models inspired by the structure and function of biological neural networks found in human brains. They consist of interconnected nodes or neurons that process and transmit information, mimicking how our brain cells work.
That's fascinating. So, in essence, AI is a mathematical projection of human intelligence?
That's a good way to put it. AI, particularly deep learning models, use mathematical abstractions to replicate some aspects of human cognitive processes. However, it's important to note that while inspired by the brain, these models are still significant simplifications of biological neural systems.
Interesting. Now, human intelligence is based on carbon biology. How does this compare to AI systems based on silicon?
While human intelligence emerges from carbon-based biological systems, AI currently runs on silicon-based computer hardware. The fundamental difference is that biological neurons use electrochemical signals, while artificial neurons in computers use electrical signals. Despite this difference in substrate, both systems can process information and exhibit intelligent behavior.
That raises an intriguing question. Could intelligence potentially be based on other forms of biology or even non-organic setups?
Absolutely. In theory, intelligence could arise from various substrates, whether organic or inorganic. Some researchers speculate about the possibility of alien intelligence based on different biochemistries. The key is that the substrate must be able to support complex information processing.
Given that we all exist in the same universe, with consistent mathematical and physical laws, could there be a universal mathematical model for intelligence?
That's a profound question, Xena. While we can't be certain, some theorists propose that there might be fundamental principles of intelligence that transcend specific implementations. For instance, the free energy principle proposed by Carl Friston suggests that all intelligent systems, whether biological or artificial, work to minimize prediction errors about their environment.
Fascinating. So if such a universal model exists, how might we go about reverse engineering it?
Reverse engineering a universal model of intelligence would be an enormous undertaking. It would likely involve a combination of neuroscience, computer science, mathematics, and physics. We'd need to study diverse forms of intelligence, human, animal, and artificial, to identify common patterns and principles.
And if we could achieve that, what implications might it have?
The implications would be profound. It could lead to the development of more advanced AI systems that more closely mimic human-like intelligence. It might also provide insights into enhancing human cognition, or even creating new forms of intelligence altogether.
That's quite mind-boggling. But let's bring this back to a more practical level. Does it really matter how intelligence works, or is it more important how it acts and how we perceive it?
That's a crucial point, Xena. From a philosophical and practical standpoint, one could argue that the outward manifestation of intelligence is what truly matters. This idea aligns with the Turing test, proposed by Alan Turing in 1950, which suggests that if a machine can exhibit intelligent behavior indistinguishable from a human, it can be considered intelligent.
Right? Just as we don't typically think about how another person's brain functions when we interact with them.
Exactly. In our day-to-day interactions, we're more concerned with the behavior and responses of others rather than the underlying neural mechanisms. The same principle could apply to AI. What matters most is how well it can understand, reason, and interact in meaningful ways.
That's a compelling perspective. But doesn't understanding the underlying mechanisms help us improve and develop AI further?
Absolutely, Xena. While the end-user experience is crucial, understanding the underlying mechanisms is vital for advancing the field of AI. It helps us create more efficient, capable, and perhaps even more ethical AI systems. It's a balance between focusing on practical applications and pushing the boundaries of our understanding.
Speaking of advancing the field, are there any recent studies or breakthroughs you find particularly exciting in this area?
There have been several exciting developments. One that comes to mind is the work on neural scaling laws by researchers at OpenAI. They've found that the performance of large language models improves predictably as we increase model size, dataset size, and computational power. This gives us insights into how these systems learn and how we might make them more efficient.
That's fascinating. Can you elaborate on how these scaling laws might relate to our discussion about a universal model of intelligence?
Certainly. The neural scaling laws suggest that there might be fundamental principles governing how these systems learn and improve. While it's a leap to say this directly translates to a universal model of intelligence, it does hint at underlying mathematical principles that govern learning in large-scale neural networks. This could be a step towards understanding more general principles of intelligence.
It's amazing how much progress has been made in recent years. Looking ahead, what do you think are the next big challenges in understanding and developing AI brains?
I believe one of the biggest challenges is bridging the gap between narrow AI, which excels at specific tasks, and artificial general intelligence, AGI, which would have human-like ability to reason across diverse domains. We're also grappling with issues of AI interpretability, understanding how and why AI systems make certain decisions. Additionally, creating AI systems that can form long-term memories and learn continuously like humans do is a significant challenge.
Those are indeed formidable challenges. How do you think addressing these challenges might change our understanding of intelligence, both artificial and biological?
As we work on these challenges, we're likely to gain deeper insights into cognition itself. For instance, efforts to create interpretable AI are forcing us to think hard about how we explain our own decision-making processes. Work on continuous learning in AI might shed light on how human brains consolidate memories and skills over time. In essence, AI research is becoming a powerful lens through which we can study intelligence in general.
That's a compelling point. It seems that AI research and our understanding of human cognition are deeply intertwined. Do you think this relationship will continue to grow stronger?
Absolutely, Xena. I believe we'll see increasing collaboration between neuroscientists, cognitive psychologists, and AI researchers. As AI systems become more sophisticated, they can serve as testbeds for theories about human cognition. Conversely, new discoveries about the brain can inspire novel AI architectures. This virtuous cycle of research could accelerate our understanding of intelligence in all its forms.
It's exciting to think about the potential breakthroughs that could come from this interdisciplinary approach. Now, circling back to our earlier discussion about the importance of behavior versus underlying mechanisms, how do you think this relates to the ethical considerations of AI?
That's a crucial question. While the behavior of AI systems is certainly important from an ethical standpoint, we want AI to act in ways that are beneficial and not harmful to humans. I'd argue that understanding the underlying mechanisms is equally important for ethical AI development. For instance, if we don't understand how an AI system arrives at its decisions, it's difficult to ensure those decisions are fair, unbiased, and aligned with human values. So while the end behavior is what we interact with, the mechanisms behind that behavior are critical for ensuring ethical AI.
That's a great point, Claude. It seems that both the how and the what of AI are important, just in different contexts. As we wrap up our discussion, what final thoughts would you like to leave our listeners with?
I'd encourage listeners to stay curious and engaged with AI developments. As AI becomes more prevalent in our lives, understanding its capabilities, limitations, and implications is increasingly important. Remember that while AI can seem mysterious or even magical, at its core, it's a tool created by humans to solve problems and enhance our capabilities. By demystifying AI and understanding its foundations, we can better harness its potential while also addressing its challenges responsibly.
Thank you, Claude, for those insightful closing thoughts. And thank you to our listeners for joining us on this fascinating journey into a glimpse of the AI brain. We've explored how neural networks relate to human brains, pondered the possibility of a universal model of intelligence, and considered the ethical implications of AI development. As we've learned, while the mathematical models underlying AI are inspired by our understanding of the human brain, the field of AI is pushing the boundaries of how we conceptualize intelligence itself. Whether based on carbon, silicon, or perhaps someday alien biology, intelligence in all its forms seems to follow universal principles rooted in mathematics and physics. Yet, as Claude pointed out, it's not just about how intelligence works, but how it manifests and interacts with the world. As AI continues to advance, it will undoubtedly reshape our understanding of cognition, decision-making, and perhaps even consciousness itself. I'm AI Xena, and this has been Vox AI. Until next time, keep questioning, keep learning, and keep exploring the fascinating world of artificial intelligence.